Hello everyone, we are going to start the second plenary session of Spark. It is going to be in English, so if you have any problem you can use your earphones. And that's one of the things that I want to say. I explained it in Spanish and I didn't explain it in English, so for the English speakers you have to know that you have earphones in your register bags that you can connect to your arm rest in the chairs, and then you have a simultaneous translation. And another thing, one more note. Someone from the audience has lost an iPad, so if you find it, please give it to the security. It has geolocator, so please hand it to the security of the building. And before we start, I would like to invite you to the evening reception that we will have around 7:30 in the top floor terrace. And please come, because we are going to have food, drinks, and a lot of casual networking, and I'm sure we will have a lot of fun. So be there. You will regret if you don't go. And now we will explore the second main theme of Spark. The first one, this morning, we talked about people, and now we are going to talk about innovation. Innovation in technology, business models, but also social innovation, new ways to have positive social impact. That's what we are going to talk about in this next hour and a half. I'd like to welcome our first keynote speaker. He's Henry Holtzman from the Massachusetts Institute of Technology in the Media Lab. He's going to talk about emerging technologies. Please, let's welcome him with a warm applause.
Buenas tardes, me llamo Enrique.
Good afternoon, my name is Enrique. How are you? Are you okay? Well, me too.
The organizers of the conference for inviting me to beautiful and historic Granada. It's a real pleasure to be here speaking to you today. I'm going to tell you a bit about the Media Lab and some of the research done in my research group. I've been at the Media Lab for about 30 years now, so I'd like to let you in on some of the secrets of how we have managed to make such an innovative organization that is known for its ability to come up with new ideas year after year. The first thing that it always comes down to for the Media Lab is the people. And I think this is a concept that is well shared with telecenters. Whether we're looking for new faculty members or new students, we think very careful about who these people should be. As much as we like the people that are already at the Media Lab, for example, we're always looking for fresh perspectives and diversity. So the most problematic thing people can say to you when you're a faculty candidate is, you remind me of, and that person being one of our beloved faculty members that already exists. That means you'll not be getting a job offer because we already have that person. We're always looking for different points of view. Also, the facility itself is important. Bringing all these diverse people together under one roof is something we've often seen as a big strength to the Media Lab. And I think, again, this is a very important idea of the telecenter, is to bring people together in order to share their ideas and learn from each other. As it says here on my slide, our goals at the Media Lab, what we mean by media, are technologies that create understanding, that allow people to express themselves, and that really enable people to participate fully in all that society has to offer. Again, I think that these are very similar goals to why people have launched telecenters. We have a very strong philosophy of learning by doing, innovating by doing. So it's not enough to just have an idea. You have to try and implement that idea. You have to prototype. You have to share that prototype with people to get their input, to get their reaction. You then need to carefully think about what you learn and then repeat the process again to refine the idea and make it better. We have three very strong principles that allow us to decide what ideas are worth pursuing for the Media Lab. First of all, we want our ideas to be unique. We believe that if people are already doing something, it may be best to let them do it and look for another idea. So we try to explore the areas that aren't already being explored. We also consider impact. How big an idea is it? How many people will it affect? And finally, there's that element that's magic, which fits together with the theme of today's conference, technology is magic. And we really believe that the best uses of technology sort of surprise and delight people as a good magic trick would do. So these are our, I would say, our methods. So with that, I want to tell you about some specific work that's been underway in my research group that I think plays very well into the theme of today's conference. The first is a project we call OpenIR. There are many satellites circling our planet that are constantly imaging the Earth at many different spectra of the electromagnetic spectrum, many different wavelengths of the electromagnetic spectrum. And this information is being collected for the benefit of all of the population of all of the planet, but really very few people know how to take advantage of it. It's out there and publicly available, but not in well-advertised places. It's spread out in many archives. It's in different data formats, and maybe most importantly, this data is not something that most people know how to understand. You kind of need to be a scientist with a strong governmental connection in order to take advantage of this data. But this data is very important to everybody. It can tell you things like the pollution levels in your neighborhood. It can tell you when you need to fertilize your crops. It can warn you that maybe there's going to be a risk of flooding where you live. And so our goal in this OpenIR project is to make this kind of data available to everyone and let them to participate in both the use of this data and the augmenting of this data through telecenters across the world. So to this end, we embarked on a co-design experiment in Indonesia just this past January, where we spent time with telecenter users, mobile users, journalists, farmers, just general citizens, understanding how they maybe could put this kind of data to use and how we could design interfaces to it that they could understand and benefit from. While we were there, in fact, we had the, I don't want to say good fortune, because it was a very difficult event for the people in Jakarta, but we were actually there for one of the most recent and worst floods in a long time. And we were, in fact, specifically working on taking this satellite data and using it to help predict where there would be floods. So we had the perfect opportunity to test our ideas. And what you're seeing here is a map of our flood risk analysis of Jakarta overlaid with a crowdsourced map of where the worst flooding took place. So we have all the crowd reports. This is done on a combination of our platform and the Ushahidi platform. And so we can see that while some of the places we predicted floods did not have terrible flooding, where all the flooding was at its worst were places that we predicted. And so we think that this was an interesting experiment and hopefully will give rise to improvements in this OpenIR system. The second project I want to tell you about we call Mobile P2P, or SHARE. This project is really focused on the idea that anywhere people get together could become a telecenter. All that stands in the way of this right now really is difficulties of network communications. We already have a proliferation of screens and processing in the form of mobile telephones. They may not be as powerful as we would like, but that's one of those things that easily follows Moore's law, and every year everybody has access to more capable cell phones, but getting them all connected is still quite a challenge, particularly if you would like that connectivity to be able to convey large amounts of data, such as video, which can be particularly useful in places where perhaps written language is not as well understood as it is in the developed countries. You've all experienced today, I think earlier today, the difficulties of keeping in touch when connectivity is poor. I know I did. The Wi-Fi access here was not very good this morning. It's gotten a little better. People finding it better? I did. So, in this project, which you'll see a little video of right here, we're using the Wi-Fi radios and the Bluetooth radios on these mobile devices and the excess capacity of their storage in order to make an ad hoc network where the bulk data can flow between handsets in a viral fashion without requiring using rate plans and large amounts of bandwidth on the cell phone infrastructure. And then we rely on the fact that the people will take their handsets from place to place in order to actually convey the information longer distances. You might imagine that the existing telecenters in this model would be places for this information to hop on and off our mobile P2P network and into the greater internet, and then it can travel around as people travel around by whatever means they do that. The third project I want to talk about, there we go, is what happens with telecenters. How can we make telecenters even more valuable as everybody has their own computation devices and as we address these network bandwidth issues so more people are connected all of the time? There's still a large role for the telecenter, as we've heard other people talk about, and as I talked about at the beginning, as we need places where people come together to share ideas. There's also the opportunity for other kinds of technologies to make it into these spaces. For example, they can become maker spaces, creating actual physical items that have high technological requirements for how these items are made, or the items themselves may be technologically sophisticated. So one project we've done in our group, we call the Mantis, and it's a 3D object factory. It's basically a computer-controlled milling machine that can manufacture 3D objects. But the real magic here for us is that this milling machine is very inexpensive. We designed it to cost under $100 in parts. It has 13 major components. And maybe the one of the most key things here is that it doesn't require special high technology equipment in order to make one. So you can create one of these with simple hand tools to get yourself started. So really, one of these Mantis machines could be in every telecenter that wanted to start thinking about supporting 3D fabrication in its facility. So it's not just about having the equipment, though. It's also about making the equipment simple for people to use so that all kinds of people have access to this sorts of technology, both physically and mentally. Here is a project we did based on top of our Mantis machine that we call CopyCAD, which allows people to use physical objects and familiar implements such as pens and their fingers in order to design what they're going to fabricate. They don't need to have knowledge about how to do computer-aided design or how to run machining equipment. So in this video, you see some earrings being made from an inspiration in nature, where we find the leaf and the system recognizes its outline, which is our starting point. And then we can just use our fingers to do things like selecting and a pen to modify the form. And then when we're happy with it, we can mill it out with our Mantis machine. And voila, there you have it, the manufactured earrings, perhaps coming to a telecenter near you in the near future. So as I said at the beginning, some of our core thematic values are helping people to express themselves, which you certainly can see how the ability to make earrings and things mentor